Hi everybody, this is Rick Morgan from Comic Book Science, and I'm going to answer a question today from Mike It came from a nerd cave who asked, do comic book slabs actually protect comic books from UV damage, as well as gases and other things? And the answer is, yeah, they do. And that's the answer, if you want to stop watching now. Pretty much, not all the way. So light, as you know, we have a visible spectrum, which when humans, or not humans, but animals that predated us developed eyeballs. The middle of the solar spectrum was at 550 nanometers. It's shifted now, but our eyes are centered around 550 to 600 nanometers. And that's not surprisingly the color of the sun. It's yellow light. So too far below what the color of the sun is, it's ultraviolet. That's higher energy. Too far beyond, which is low energy, that's infrared. And we're more concerned about the stuff that's higher energy because it's damaging to the dyes and pigments in our paper and the cellulose fibers as well. So we're going to do some experiments today to figure that out. You should know that what does red mean? You know, what are these colors? So if you see conjugation, which means double bond, not a double bond, double bond, not a double bond, usually means red, especially if it gets to a certain length. If it gets disrupted in some way with little tiny hydroxyl groups or other functional groups on it, that can change the color to orange or purple or other stuff. And in the case of like phenolphthalein, if the conjugation is broken completely at a different pH, it can either be sort of a pinkish red color or clear. It switches back and forth pretty rapidly with pH. Most blue things, I shouldn't say most blue things, some blue things have a metal in the middle. They're a ligand. So the ligand is like a copper or zinc. It'll turn a bright color. Or they're conjugated with nitrogens instead of with regular carbons, and so you'll see we call those we call those chromophores. They're chromophoric, and we can tell by looking at them they're going to be colorful, but even if we don't know what color they're going to be. So we're going to do some experiments, and I have a UV-AB sensor here and a data acquisition system, and I have UV light, and we've got some materials. I'm going to set up an experiment, and we're going to see if they really do protect from UV and how much. And to sort of calibrate our system as a control, we're going to use some UV transparent film with some SPF 15 and SPF 70 sunscreen on it to see if that makes a difference. We'll find out. Also, my microphone broke halfway through the experiment, so I'm going to have to narrate some of it for you. I apologize. Take care. Bye-bye. I forgot to mention one thing, and that is that most people think of that the UV light is damaging to your skin and to the pigments and things because it breaks the bonds in them. And it's not true, actually. It's actually making bonds in your DNA and in your skin, how flexible your skin is. Most things are actually bonds created by the UV light. Now, UVC is not making it to the earth, but the UVA for aging and UVB for burning are doing this damaging, and they are doing it by making bonds and not breaking them. I just wanted to be really clear about that. Same thing with the red dye. It's making bonds in the red dye. It's not breaking them. Bye. All right, so what you see here in the little screen is our setup, and we have a UV light. The microphone broke, so I'm going to have to narrate some of this in post here. So my small camera on the right is showing you they have a UV light and a detector pointing up, and I'm getting a baseline. At the bottom you can see the blue line growing. That's the baseline. It's around 30 milliwatts, and if I turn the light on, it jumps up to around 19,000 from 30, so the light comes on, so that's a lot of UV intensity. And I sort of let it stabilize. And then the first thing we do is Nolan will help me put a UV transparent film with some SPF 15 sunscreen on it, smeared with a credit card to be used even when it drops about that much. And that drops to about 44% of its original value. Then we do some SPF 70 is the next thing we put on there, and that drops quite a bit more, actually. It drops to around 11% of its original value. Let's see if we can get to the SPF 70. That's this one right here. So put that in, and it drops quite a bit. There it goes. Way down low. So that SPF 70 was a big difference over SPF 15. We're sort of calibrating that our system works when we put things that are supposed to absorb UV. Now there's a poly bag. Put that in. And as this 2 layers thick, it drops to around 19 or 81%. It drops by 19%, and then I do just a little, just half of it to see if it comes back up, and it does. So, you know, it's overall you're losing about 9 or 10% of your UV intensity with a polybag. Not a whole lot. Then we try Mylar. All right, Mylar, what do you got for us? And Mylar drops about the same, maybe a little less than poly. I'm sure thick Mylar would be different than thin Mylar. Then this is a Spider-Man book and a CGC case, and we're checking it out, seeing how well it works. Now this is double thick, so imagine you're getting half of this on any one side. I have to break one of these things, and it drops quite a bit. It drops down to 13% of its original value. It does a great job, actually. And you can see, I'm just trying to show you that it's fluorescing here. So there's a lot of stuff in that case that is helping it. So it does a great job. It's actually very much absorbing. This is another book here. This is Amazing Fantasy 15. This is an early Spider-Man book, but this is in a PGX case, so it's a different brand. And we're going to see how well this one absorbs UV light. So we're going to put that one here, and it goes down to only about 40%. So you know what? It's not as good. The branding in the slab, shocking though that is, makes a difference. One of them probably has more fluorescent dyes in it that absorb UV than the other, and it's not as good. It's almost as good, but it's not as good. And the last thing we have is a top loader. This is a regular top loader, and it drops to about 60% of its regular value. So the CGC slab is really absorbing in the UV. Now, it's not entirely absorbing. Would you catch me putting my books in the sun in this? Nope. But it eliminates most of it, probably around 85%. And I'm just trying to show you how well this plastic fluoresces in the UV light here. It really does a fantastic job. That stuff really glows. It's not as apparent on the screen, but it was glowing really bright blue. You could tell that it was fluorescing quite well. And the PGX case with Amazing Fantasy is not as much. That plastic is not as good a plastic. It's definitive now. Yeah, that's it. So if you want to protect your books, the CGC slab does a better job. If you're going to have them out in daylight, it makes a difference. It really does. Now, of course, you're going to break those things down over time, and it's not limiting all of it, so you're taking a risk. But overall, it's true. It really does work, and it really is better that way. For those that want to see this over again, the left square is SPF 15 sunscreen, reducing it to 44%. Followed by the purple color box, we have SPF 70, reduced it to 11% of its original intensity. The polybag reduced it to 81%, and that's double thick. At half thick, it was only 9%. Mylar at double thick was at 78%. Then the red oval is the CGC slab that ended up being at 13%. Good job. The 41% was the PGX slab. And then we had the top loader at 60% of its original value. I hope you enjoyed the video. Take care.